In this video, I'm going over the questions in the Mock 4 review. So starting with the rational expressions, the first question here is just simplifying. I notice in my numerator that I have a difference of two perfect squares because I can take the square root and you have subtraction. So the numerator could be factored as x plus 4 because the square root of 16 is 4, then times x minus 4 over than in my denominator. Well, I notice here I have the two terms, but I have a GCF. So I have a GCF of 7, but they also both have x. So 7x. When I take out that 7x, factor it out, I'm left with 1x still, but now 28 divided by 7, which is 4. So in the denominator, I have 7x over times x plus 4. So now I can cross out and eliminate the x plus 4s. So notice here you're left with x minus 4 over 7x. Now, question number 2, you're dividing. So we do now for this one need to do keep, change, flip. So keep the first and then multiply by the reciprocal. So I'm going to flip here the second. And now I can start factoring my numerators. So here with the trinomial, you're going to go right into the parentheses because n squared is by itself. It has that coefficient of 1. A is 1. So the numbers here that multiply to get negative 28 but add to get 3 are positive 7 and negative 4. Then here you have two terms. Now it's not a difference of two perfect squares, kind of like here the x squared minus 16. That is just, I have a GCF of 9. So I can take out a 9 here. They both don't have a variable, so just 9. 9 divided by 9 is 1n, and 81 divided by 9 is 9. So for the GCF, I'm going to go ahead and put that on the out, so out in front. Then here, n plus 9. Now focus on the denominators. Well, that's just n minus 4, so I'm going to bring that down, n minus 4. Now here I'm back to two terms. I have a GCF of 2, but notice how they both also now have an n, so 2n. Then times, well, n plus 14 divided by 2, which is 7. So I'm going to again put the 2n on the out, and then n plus 7. So here, when simplifying, I can take out the n plus 7 and n minus 4. And here you're left with 9 times n plus 9 over 2n. Nothing we can do about 9 over 2, so I'm going to leave it as is. Now, question number 3, this is just multiplication, so no need for keep, change, flip. So I'm going to go right into my factoring my numerators, right? Because we're just multiplying straight across. Well, nothing I can do here about x plus 3, so I'm just going to bring that down. Now here I've got my trinomial where a is 1, so it's by itself. So what numbers multiply to get you negative 40 and add to get you 6? Well, 10 and 4. So x plus 6 and x minus 4. Then the denominator. Well, here I have my two terms, and I notice I have a GCF. I can divide both out by 4. So here 4 divided by 4 is 1, so just that 1x plus 4 divided by 4, which is also 1. So now I've got 4 times x plus 1. Now here, I'm now back to a trinomial. I can go straight to parentheses because a is 1. Then what numbers multiply to get 30 and add to get 13? 10 and 3. So x plus 10 and x plus 3. So now when I cancel out, I can cancel out x plus 3 and x plus 10. And now I'm just left with final answer, x minus 4 over 4 times x plus 1. Question number 4, Elena was given this problem and she simplified it to this expression here. But which of the following could she have simplified it to? Well, I notice in A is not going to be my answer, and here's why. Well, if I multiply, that's 2 times x minus 12. So if I were to multiply that right straight across, so distribute, that is 2 times x, which is 2x, but then minus 2 times 12 now, which is 24, which here I need 2x minus 12. Now the next one, I have division. So I'm going to keep first, but multiply by the reciprocal. So I can already tell that this is not my answer because now notice how x minus 4 is in the numerator when I need it in the denominator. Notice how this is in the denominator. So B is not my answer. Now I notice before I continue on and simplify C that x minus 7 can cancel out. So here I've got just in my numerator 2 times x minus 6. Now, if I were to distribute that, I do get 2x minus 12 in my numerator. So far, we match. So now I'm going to factor the denominator. Well, here I can go straight to parentheses. So what numbers multiply to get 20 and add to get negative 9? Negative 5 and negative 4. And notice how that is what we needed, and that's why here the answer was C. So question number 5. What values make this expression undefined? So here in this case, guys, remember, I don't need to factor because if I'm looking for what are the values that make this undefined, remember a fraction cannot be divided by 0. So I'm only going to focus on the denominator. That's it. X squared minus 10x plus 24 cannot equal 0. So now as I go through, I can solve this by factoring. And I can go straight here because A is 1. So what numbers multiply to get 24, but add to get negative 10? Negative 6 and negative 4 cannot equal 0. Then remember, it's just like when we were solving. This means x cannot equal not negative 6, but positive 6 and positive 4. So that's why the answers are C and A. Questions 6, 7, and 8 are the I operation. Now here I've got 5 to the third power. So 5 to the third power is 125. Then I have I, then remember power to a power, think of parentheses, so multiply. That's 3 times 3, which is 9. Now I can go through and use quarter method, divide by 4, and you get 2.25. So this is 1 quarter. So I still have 125, but now times I to the first power. I to the first power is I. 125 times I is still 125I. Now, number 7, it's been a while, but again, just to practice simplifying when you have the negative square root of a negative value. So like, for example, square root of 16. Well, square root of 16 is a perfect square. It's 4. So the square root of negative 16, right? That's the same as the square root of 16 times the square root of negative 1. And what is always the square root of negative 1? I. So that's why here you have 4I. Then times, well, here this is the square root of negative 8. So again, the square root of 8 times the square root of negative 1. So I know I need I because the square root of negative 1 is I. Now 8, though, is not a perfect square, but I can simplify this to the square root of 4 and the square root of 2. And then here the square root of 4 is 2. So 2 radical 2, then I. Now we are multiplying that by 4I. Well, here I've got 4 times 2, which is 8. Then nothing I can do with the radical 2 here. It's all by itself. So radical 2. Then I times I. Well, I times I is I squared. Then remember, I squared was always negative 1. So that means negative 1 times 8 is negative 8. So that's why this is negative 8 radical 2. So question number 9, again, 8, powers of I. So first off, I'm multiplying. So 8 times negative 3 is negative 24. Then remember, with the exponents now when multiplying, we're going to add them. Keep in mind, this I also has an exponent of 1. So that's why this is not 23, but 24. So now when you do the quarter method and divide by 4, 24 divided by 4 is 6, a whole number, which is like 6 whole dollars, right? And then here, that means I have 0 quarters. So this is negative 24, but then now times I to the 0 power. And I to the 0, anything to the 0 power is 1. Negative 24 times 1 is negative 24. Question 9, 10, and 11, focusing on our quadratics now. So here, this is solving, given this function here, we're solving for x. So I'm just going to rewrite this here, 20x squared plus 360 is equal to 0. Now, notice this is just back to our 2 terms. So 2 terms, no x, treat it like a 2-step. So we always add or subtract first. So I'm going to subtract 360. Now I've got 20x squared is equal to negative 360. Still can't take the square root yet because x is being multiplied by 20. So now divide by 20. Now I've got x squared is equal to, that is negative 18. Now I can take the square root. So when I take the square root here, well, I notice right off the bat that I'm going to have I in my answer. So square root of 18 times the square root of negative 1, so I know I need I. Then the square root of 18 I can break down into 9 times 2. Square root of 9 is 3. So x is equal to positive or negative 3 I radical 2. Question number 10. We are back to factoring, but notice how it's a special case of 2 terms. So I notice because I'm adding, I do need I in my final factored form. So I'm going to mark off C because there's no I here. I do notice from my answer choices, I have a GCF of 3. So here I'm going to rewrite it, but now take out that GCF of 3. So 3 times, that is 4x squared now, 12 divided by 3, plus 25 from 75 divided by 3. Now keep in mind, I still now need to factor this. So that shortcut here, they're perfect squares. This is factoring the sum of 2 squares. So now I take the square root. Square root of 4 is 2. So 2x plus the square root of 25, which is 5. So 5i times 2x minus 5i. So that's why here the answer was D. Then question 11. Again, here I notice I have 2 terms, but now I'm subtracting. So no need for I in this answer because this is subtraction. So I'm going to mark off C because there's I in the answer. Now I do notice that there is no GCF, so we can go right into the difference of the 2 perfect squares. Take that square root. So now square root of 25 is 5, so 5x plus the square root of 64, which is 8. So 5x plus 8 times 5x minus 8. That's why here the answer is B. Then question number 12 and 13. Then here I'm going to stop this video after these 2 questions, and then I'll create another video for the second half. So question number 12, this is about the number of solutions. So this is again b squared minus 4ac, where we find the discriminant. However, if you notice, and I'm going to rewrite this, my equation 10x squared is equal to negative 4x. When we need it, equal to 0. So I'm going to first add 4x to both sides. So now that my equation's equal to 0, I have 10x squared plus 4x minus 1. Now I can identify my A, B, and C. So b squared, which is 4 squared, minus 4 times A, which is 10, times C, which is negative 1. So now when you put all that in the calculator, if you're calculating that or calculating by hand, you get 56. So because this is a positive discriminant, that's why the answer is A. There are 2 real. So question number 13, we're solving for x. Well, I notice I need to distribute. So here I've got x squared minus 8x is equal to negative 5. But again, equal to negative 5, it needs to equal 0. So now I'm going to add 5 to both sides. Now the equation's equal to 0. X squared minus 8x plus 5. Now I notice there is nothing that multiplies to give me 5 except 5 and 1, but they will never add to get me negative 8. I can also notice from my answer choices that we do need to use quadratic formula. X is equal to our negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to first focus on the discriminant, b squared minus 4ac. So here's my a, b, and c. So this is negative 8 squared minus 4 times 1 times 5. So now here I get a discriminant of 44. Now because this is positive, I don't need I in my answer. So I'm going to mark off C and E because the discriminant is now positive. Now I'm going to continue with my negative b here. So x is equal to negative b, which is negative 8, plus or minus the square root of the discriminant, which is 44, over 2 times a, which is 1. Now here I notice two negatives making a positive, so now I'm at positive 8. However, the square root of 44, well, I can break that down to the square root of 4 times the square root of 11. The square root of 4 is 2, so this is 2 radical 11. So here I've got 8 plus or minus 2 radical 11, but still divided by 2. Now I can simplify because here I can divide. 8 divided by 2 is 4, and 2 divided by 2 is 1. That's why here the answer was B. Now I'm going to pause the video here, and I'm going to create another video for the rest of the questions 14 through 24.